Hello, Amiga coders. This is Photon of Scoopex, welcoming you back to another episode. Um, we had some tweaking left to do, and one of them was to reduce the number of clouds. I did prepare the previous episode because I knew I was filling up the raster time, uh, but I must have restarted the emulator without saving the 7 megahertz. Because when I run it now in 7 megahertz, I get a frame overrun. So I've reduced the cloud count by one. I removed one small cloud, but it still looks good. And I did some other changes that we can check out right now. So I've worked on this a little bit beforehand. I don't like to do that. I like to involve you, and you will get an idea of common pitfalls if you're unprepared or rusty like me. Enough self-punishment. Let's have a look. So what I did was, first of all, mirror the clouds in the reflective plate. I struggled a bit to find muted enough colors to sort of blend in with the plate, and I also made it so that the lines in the plate at the bottom go on top of the clouds. And we're going to do the same for the raster bar. The raster bar is also a background color change for 5 lines, and also needs to be in front of the plane data, up there by the logo. And those are most of the changes. It just didn't seem fair to have you start the video watching me change colors for half an hour. I can show you the changes real quick. Let's go to the copper. And let's take this moment to scout out where the cloud colors are. There they are. I went ahead and added a label here to separate them. Apart from that, the only changes I've made have been to the cloud count and the bottom of the copper list. So one thing I did was, in between the two clouds, I made a palette change. So in the middle of the clouds here is a palette change to tone the clouds down a bit because they stuck out too much against the darker background towards the horizon. And these are all, you know, design decisions that you can make however you want. And it's going to be up to case by case. So I did these by editing in hex, which might not be the best way of doing it, but the alternative way is to export the palette somehow into Deluxe Paint and use the spread option to get the middle color of 3 in a row to be in between two colors that you want to fade. And here's where the bottom plate starts, and here's where I added a weight to the end of the line because that is recommended for modulo changes. And here's the reflection. And what I did was copy the first occurrence. I think I have it on a key here. Of the even bit planes modulo, which is here. So because the display is interleaved, and because it's 3 bit planes and you display one of them, here you skip 2 bit planes. So the 3 bit planes minus the number of bytes you show, to be precise. So I copied this, but instead I wanted to change this to a plus because I want to skip, and when you skip forward, you skip over 2 bit planes. When you skip back, you skip ahead 3 minus 1, And when you skip back 3 plus 1, because you've already displayed this amount of bytes. So that is indeed what I did. So simply adding that to make it 4-bit planes and negating it creates the mirroring. And in the bottom plate too, I made an even darker palette to create the illusion that it mixes in. It's not fully reflected in the plate. It is tinted a little bit by the material of the plate. And down here we have a weight that sets a high color, and then I copy that color to the cloud colors, thereby replacing them, making them all the same, meaning they are no longer blocking the background color line that I had there. Well, they actually are, but they're the same color, so nobody knows. And on the next line, when it's reverted to this plate color, I restore the cloud colors. And same down here, because 2 clouds crossed 2 lines in the plate. So that's so much for the plate and the mirror effect. Now for this is actually very similar. What I'm doing here is very similar to what I will be doing with the raster bar. Remember that in order to make the raster bar sometimes appear in front of the logo, we had 2 tables that we read from, one called bar behind and one called bar in front. With the one in front replacing the logo colors with the bar colors, which is what I'm doing here, putting it in front. And then when it's all done, I restore the colors below the raster bar. So that is our next job, to put the clouds behind the raster bar technically, without doing so, because you can't put anything behind the background color. So let's have a look. So we are struggling a little bit for time. I don't know if you remember, but we have between 1 and 4 raster lines of time left until vertical blank at the very bottom. And whether it will still cause a frame overrun depends on the music and maybe not a whole lot of else. So we may have to look at optimization later, but for now, there's no reason to destroy this code and replace the loop with a repeat or something like that, because the bad thing about optimization is that it's always premature. And that's why bloat. But you can wait until the very end to optimize, and then you will leave your source in a readable state for as long as you can. So here we have the loop. It reads 6 times, 5 times for the raster bar, and the 6th time is to restore the colors. And these should reflect that. So when it's in front, you can see that all the palette colors are the same color. And what we'll do is we'll add 7 colors. The 7 colors of the other playfield. And this is not very pretty, but it will do the job with readable code. And that's the main point for now. We'll have a look at this somehow should cause a frame overrun. We'll have to fix either this loop or do something else. We could split this up in two. That would make it faster every other frame. We shall see. And then is this a macro? It certainly is. So let's make a similar macro for the cloud colors. And I spotted them. So that I can remove the copper commands from them. Just have the color values. I seem to have done exactly the same operation at some previous point in time. These raster bars have been with us now for a long time, almost since the beginning of this series. In the very first episodes, we did a raster line with the CPU without the help of the copper. Waited for mouse button press. And then this was one of the earlier things we added. So that is the cloud colors palette, and I need to go back now and make sure that when we restore the colors, so here's the raster bar, 1 line, 2 lines, 3 lines, 4 lines, 5 lines, and restore the palette. And now we do the same for when the bar is behind. And that will, should have copied that. So this is all we have to do for the data. And we just need to make some room in the copper. Need to put some empty colors in there to be poked by this loop. We can do that right now. And remember, only 7 colors. Now we are setting quite a few colors here after the horizontal blanking. This is the earliest horizontal position on a new line. Any lower, and it reverts to horizontal position E3, hex E3. This meaning that horizontal position E1 is the highest horizontal position you can set for a copper weight that stays on the same line. So we'll see if we have to move this weight. We could also, thing is, if I move this now, I could move it, but I would get, because I changed the background color, I would get a stagger in the raster bar. And I want to avoid that at all cost. I can demonstrate it. I can lower it to 5. Now I can't run this yet because I've changed the structure without changing the code that writes into it, and it's sequential, which means that it will start putting wait commands here in the middle of the color data, and we will have a mess. So we need to simply copy this. So again, this is the background color. This is the horizontal position. Sorry, the vertical position. And we need to set 7 more colors. We could use a space here. second playfield. And we're still reading from the structure. And we just need to increment this set here. And that should be working as is. We haven't changed the spacing in between the points in the copper list for each line. Yes, we have. Glad I talked to myself. We need to add 7 to this, of course. And that worked just fine. Let's double check that. Let's check the clouds. We have the interesting effect that when the raster bar switches from behind to in front, it also switches to behind the clouds and in front of the clouds. But you can see, you can barely see the stagger in the right margin. We want to avoid that. So the way to avoid that is to adjust the data structure so that, I don't know, so that the background color comes somewhere in the middle, then reorder the copper and do all that stuff. I'm going to change it back to 07 and see if the clouds are okay. And I'll have a look at what change I must make to the data structure to make it always in front of the clouds. So basically these should be copied because the bar shouldn't, so this should go away and be replaced by the stuff from bar in front. So let's make sure we grab exactly 7 of these. Well, I can just copy this 7 times. And that was correct at the end, because that's the restoration. So let's see if we fix the raster line for good, and then we can move on to something more interesting. I'm looking at the left margin now to see that the bar is never behind the cloud. Well, the clouds are on the left margin. That looks good to me. Yeah, that looks good. So, we are getting closer to finishing this demo. Now I will return to this demo because it's now, when it's finished, we have a finished piece of code that we can adapt to other things or play around with or add parts to. But for now we want to do something with the scroller. Let's check. Right now we just have this and then a 0 to signify that it's supposed to wrap. First of all, let's get the scroll text in here. I have some junk at the end here. Well, I guess I can keep that. It's fine. Well, take care of ourselves. Let's put this here, paste that. Now this is still being kept to form to basically clear the clear the scroller off the screen so that it doesn't start over immediately. We could remove it and I could show it, but we'll have to wait till the end of the scroller to check that. Now I'm not sure I drew all these characters, so let's move them out and see which ones we can use. Let's do this. We also use this. Do use a parenthesis and a colon. Well, I sort of want some other characters so that I can see if I can replace them or anything. So parenthesis is, I don't know what to do about the smiling at the end. It might look bad. We'll have to go with the flow. So we have one scroller command here. Now there are two ways of scripting things in demos. One of the methods I have been using, well, technically 3 or more, you could have a script. And what I've ended up with is something like this. A frame number and a bit mask. And maybe something like a value. Plus the bit mask at the end. And then you'd have a bunch of these, and one of them would tell the demo to restart. Now, to do that for this scroll text would mean that I would have to find the frame at which it wraps in order to make it wrap. I do have the command already to make it wrap, but if I timed anything else to the scroller with these timestamps, I would have to add code to this wrap, this 0 detection code, signifying wrapping. I would have to add code to that to reset the frame counter. We haven't added a frame counter yet. I can show how to do that. And you can also sync stuff with the music, which means essentially that you could script a demo with your protractor so that you'd use certain effect commands, such as the 8 command and some others, 1fx commands and things like that, to turn off and on certain effects to may or progress to the next part or whatever you want to do. Meaning that you could then you wouldn't have to worry about the exact frame count. You wouldn't have to measure that or stop the demo there because you want the change there and denote the frame counter and enter it into a table. You could just listen to the song and yeah, this is about where this next part should start, and then you just add a command there. You detect it through, for example, the P61 play routine or another play routine and act upon it. Now we're not going to use this script, so I'm going to remove it, but I can show you where to put in a frame counter at least. Now that must be done in each part. It should not be done on the vertical blank, because if you do have a frame overrun, the vertical blank will still be going, but the part will be behind by 1 frame, and this might add up then. Because the vertical blank counts hardware frames, and the hardware frames are always 50 frames per second. But let's say if you had a part that updated every 2 frames, frame rate, or you had vectors where the frame rate varied, this is the reason why you have to put it in every part, or have some macro or common function or something like a frame loop init function that takes care of that for you. And you would then, after the frame has been completely rendered, you add 1 to the frame. And that's all there's to that. Your script checking code would then read this variable and sync whatever events you want to happen. So that is that. We're not going to use that. We're going to use something interesting called scroller commands. I don't know that there's an official term for it, but it's simply bytecodes that you put in your scroll text, and that code can be any code that you detect. Obviously, if you select code 65, which is the ASCII and ANSI code for capital A, then you can't have capital A's in your scroll text. So normally you can use, let's say, codes 0 through 31 or codes 128 to 255 if you're not using ANSI codes. And these are then free of conflict. So let's do that. Oh, we have one more thing to do. I almost forgot. We can do a small optimization, a memory optimization. And then we have to look at the copper again. Let's have a look. Where the plate starts. So hex 108 minus hex 2c. $220, meaning that since the buffer is reflected in the plate, we no longer need to make it as high as the screen. 220 pixel suffices, and that will save some chip mem. Times h plus 1. Why can't I remember? Sky buffer, perhaps? No. Let's have a look at the copper. Contains zeros. Let's have a look at the init. Simply called sky. +1, why? Also, is that let's look at our trusty plot bob routine and see what frickin' buffer we're poking into. Sky buffer list. Woe is me. So we almost made a boo-boo there. I'm glad I checked here because hang on, never mind. I was thinking about the init code that clears the buffer. I think we shared a loop there. Now, if you don't want to optimize this, that's fine. A cruncher, if you crunch the demo, will remove most of the excess, and that'll be fine. In fact, it's BSS, so it's just going to be wasting RAM. How am I not seeing it in the init code? That's where we poke them into the sky buffer list, so we're definitely changing the right buffers. And this is still correct, we're just counting the words, not the lines, which means it's safe to change this. So that is that taken care of. And now we go back to the scroll text. So that just starts the blit then. Not exactly what I was looking for. I can see where we load scroll text pointer. Oh, we do it in the main loop. Interesting. I will show how to structure your code better. Move code into functions. For now though, I'm glad I found it. So while that's going on, are we blitting some more directly after? Because then we could save a few scan lines rest of time. We seem to do so. We could move the cloud plot to the top, actually. That will then have a blit at the end that will cover some of the CPU code in the main loop. And I will be taking advantage of the 0-bit planes during vertical blank. We'll have a look at that later. For now, we're looking at the scroller. So all we do is a hardware scroll and then check if we have a character to plot yet. And if we don't, if we do, we plot it. So here's where we add our commands. We should have a check for 0. We don't. It would seem we don't. Here I do something special. That's kerning, centering the I think. What the heck is it? Scroll? Oh, that's the counter from 16 to 0. We have a fixed speed here. I'm not sure if I'm going to mess with the speed, but you can add a scroll command to change the speed of the scroll as well, and you can bind it to a button or something and let people who are in a hurry read the scroll text much faster. So we are checking. That's the wrap for the counter for the width of the characters, to be correct. It's called no plot, and I still go on to plot. I'd rather call that no wrap text. And I'm going to immediately test if that assembles, because some other piece of code might use the no plot, which calls plot jar. So I'm just going to assemble it to check for missing symbols. That worked well. So where do we put our command detector? Well, it's when you read the character, and unfortunately I think that's in this subroutine, which is not ideal. Because now, well, what it could do is force read. When you read a command, you must read the next byte after, and maybe more bytes until you're satisfied, and then finally read the next character that is to be plotted. The main point is that this is where we read the ANSI character from the text, and this is where we should put our check. So to make this transparent to the rest of the code, we must handle the code and replace it with a proper character, a non-command character. So I thought we had a 0 to make the scroll text wrap. We could replace the code that we have in the main loop right now with a check and put the no wrap code in here, which might be a good thing. Let's have a look at it. That is to say the no wrap text code. Let's do that. And we'll insert a 0, and that will be our first test command. There will be a minimal change to the code. So we can keep some of this code. I'm going to skip this if it's anything but 0. We can remove all this, and we'd like to replace the 0 with an actual character, the character at the very start of the scroll text. So now we can insert a 0 at any point in the text. We'll see what happens if we do that after just a few characters, and you'll get an idea. So let's have a last look at this. May need a branch here later on, but not right now. And let's just put these. So that should display a dozen characters, and then wrap, and then keep feeding text from the very start of the scroll text. As you can see, these characters are not well defined. So let's temporarily remove that and do this. So let's remove the offending characters that were not drawn. Might also have messed up and every character is borked now. Sure enough. I think we have a missing load. We need to load the scroll pointer into A0 in the main loop still. And that should fix it. Then it goes on. It's not as intended. The text is certainly working, but it's not wrapping the second time around because we haven't updated the scroll pointer. Let's make sure we don't use the scroll pointer anywhere. So restructuring code always comes with, you know, some danger. Amiga coder, this is a photon presenting it's completely ignoring it. The fuck? Sorry for cursing. Move the blit weight all the way up there. That's not necessary. That'll save some cycles, but that's not the problem. So if it's 0, this code is executed. This pointer is reset. The pointer is stored in the scroll pointer. And we fetch. Oh, need to do this. But I'm not sure why it's not taking, as it were. Oh, here we go. Why am I increasing the scroll pointer by 1 here? Am I saving and restoring register? I sure am. I don't know that I need to, really. This is the problem with having the command handling inside the plot instead of inside a big function that handles both the scrolling and the plotting. So all our work is undone at the exit here, so we need to remove this. We can replace it with something perhaps, but I think it's fine to just comment that out. And that will also save a few cycles, like a sixth of a scan line, something like that. Probably a little bit less. Now, whatever changes we make to A0, oh boy, okay, look at that. So this one should update scroll pointer, not the main loop. And then I can remove the ugly add q dot word in the main loop. So whatever happens to A0, we save it back after the command handling. And that should be fine, really. And then we can save something on the stack. Let's see what we use outside the loop then. It would be neater to have the scrolling and let's put a split here. Now this handles the kerning, I believe, so we'll leave that as is, and it operates on the last character, not on the scroll pointer. In fact, nothing here operates on A0, so we can move it down here. I want to move it back up again if we do anything with it outside the plot, but for now that's fine, and then we can store it back. This probably means I can move it into the plot routine. I don't like it at all. I would like this code above plot chart to also be in the scroller. I'd like to rename this to handle scrolling and move all the code related to scrolling into it. But for now it's okay. Just need to make sure we write it back before we overwrite it later in the code. And there might be quite a few saves on the stack that we can optimize and shave off some cycles with. We'll see about that. Premature optimization is premature. This is a photon presenting, but now at least it wraps. So everything works as it should. We've rooted out the bugs. And we can get work on the scroll text. Let's put this back in. And it will show mostly junk. I have exclamation point and dash. That's the extent of my, let's try a slash. You should have comma, dot, dash, and slash at least. And I can use slash for something at least. And I did. So let's use the slash for spacings. I have plans for this. So we have one command now. We have the 0 command, which wraps the scroll text. Currently, that will change when the last character changes. So need to do this. Let's try the slashes or dashes or a combination of the two. No, I'll use slashes. Bit of breathing space is fine. And I can't really have a slash here because I'll do the wrong smiley. How about an exclamation point? Then we have some spaces at the end. To make the wrap a seamless one. Well, this should be fine then. And then we'll have to figure out I'd like to make a command that prevents the scroller from bouncing and then maybe start bouncing here. Let's try our hand at that. And we can decide what the command should be already. I'll start it with the one command and create the command. Create the code for it. I don't have to do that. I can continue here. And what I like to do is to compare to space and everything below space. Well, it's more readable like that. And then check the specific commands. And I'd like to not put the code, well, affecting the bounds of the scroller in here. I'd like to set a flag that I read at the point in the code where I decide which vertical position the scroller should have. So let's just do that. We could do that with bits. That would save a few bytes, but it's slower and we need cycles. So let's do this. We could make it a toggle. And set it to bounds by default and thereby save one command. Otherwise I'd use command 2 to Command 1 to turn off the bounce, Command 2 to turn on the bounce. But I can toggle this. So -1 means all bits are set. It's not really important what value you set it to. It's all in the interpretation at the other end, which we'll get to now. So that piece of code will be where we read the bounce from a table that we have, which is here. No, that's a raster bar. I sure am protective about my registers. I have these standard boilerplate movem's everywhere. We'll see if we have to remove them. And we do that with acceleration. And then we just change some pointers. We should definitely reduce this movem to whatever registers we use at the end of this. And all we do is test flag bounce. You can use this in games as well to turn on and off events and have objects turn on flags that affect other objects. Let's say you take an item, you set a flag that makes an enemy go attack you because let's say you go to a beehive and take the honey and then get a flag and the bees come after you. Or whatever you like. So if that is 0, then we go to no bounds. Which is already there. What am I checking for going there? And we'll just see, I want this at the bottom. We'll see if it lets me. I think I might start it at the top because I need the acceleration. I thought I read from a table. And then I could start at any point on the table, but I think I need the elevation to make it start, accelerate, and bounce. And that's all we needed to do. To add command number 2 to need an even here. It's generally not recommended to put variables in between functions unless you need a table lookup that needs to be near the source that looks up the data in it. But for now it will be fine. It will crunch better if you put all bytes together and have a single even statement at the end. So that is that. And again, I look at the clock in the corner. I've asked a question on the WinUAE support forum why the real-time clock is not working. It's not 4 a.m. here. It's fairly late. Nowhere near 4 a.m. So what are we looking at here? We're not bouncing, we're not doing anything, we're not seeing any scroll text of any kind. So first of all, let's undo the last change we made. So the question is, why does no bounce make it not scroll? So I start here at this. If it bounces, I set the Y speed and I write that back to bounce Y. It might be outside the screen, but how could it be outside the screen? Is it never? That's sneaky. Need to move this up and that will work. It had some trash value. D0. Oh boy. Talk about a trash value. How is reading that and sticking it back incorrect? When reading it down here is fine. Maybe I'm counting on this being executed on the first frame. Fine. We'll not sort that particular. It's not really a bug, it's just about how the code was written once upon a time. And we'll just do this. So now we can no longer use the toggle, I think. Bouncy bouncy. Reminds me of a Monty Python sketch. Sure, fine. I know no better than to do that. And it's still bouncing, even though I overwrite the Y position. If this is set. Oh, it's inverted, isn't it? So need to do this. So what happened there was the variable was called bounds and I was testing for no bounds. I think I could see a stutter there. I'm gonna have to fix that. However, that is not the Y position I want. I would like it to start bouncing from the bottom, but I'm not sure that the code is compatible with that as written. And what do we compare it to? We just compare to speed, no? So when it goes to negative, it bounces, so it's inverted. So 0 should do me, hopefully. Might stick it all the way into the plate, but we'll see. No, that's fine. Might look better with this, actually. Didn't do anything, so I think I stuck it into the plate a little bit. Why isn't it moving? I had ×4, didn't I? No, ×8 actually. Well, now it's moving. So 1 × 8 should give me a 1 pixel gap. Well, technically a 2 pixel gap, right? If we're doing the mirroring correctly. But again, it might look better this way. I think I'll keep that. Which might mean that we are... Well, we won't fix that right now. We'll have this discrepancy and live with it. Now, let's fix that. Too generous move M. I don't really know if I am... Here's the thing. We want to detect when it happens because we probably need some init code when the bounce happens. We can test it right away by checking bounce Y. Initialize that to 1 × 8 now. Go to our scrolltext, and after a few characters, toggle that back, make it start bouncing. So after this sentence, I definitely saw a stutter there. Yeah, that is exactly what I wanted. So command 1 is done. And I think I want this. Now, the codes are detected in the right margin, which means we need to start the bouncing when enough characters are on the screen, and I don't know the count for them. So we'll just make sure that we remove these. And we'll have a look at it. And I'd like to move this there and probably have it something like this. And I'll fix that, the underline, after. So when this many characters are displayed on screen, the command will take effect. You could remove that. You could decide on some other position on the screen, like the center or the left margin, and then scan ahead and save. that position, but that is too much work for me. And this is how I've always done it. I've let a few characters in on the screen, triggered the command, and timed it that way. But it's bouncing. It's not supposed to be bouncing. And that is because flag bounce is by default set to bouncing. AJ. So after Asmskool and a space, I think. It even does a small bounce. I love that. I have no idea how or why it does that, but it looks awesome, so I'm keeping it. That is fine. I'm happy with that. And then when it comes here, I would like it to stop and bounce. So we'll do not the most pretty formatting here, but for all intents and purposes, if this scroll text were a living document and you would make a lot of changes, you would drive yourself mad if you made a smooth right margin on every line. You can move some text up here though to save on too many. Trust the scroll text to describe what you're witnessing with your very eyes. It's just filler, okay? I have some spaces around that, thank you very much. And we're going to count the characters. I don't think the spaces were on screen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And that's our second command, which we have not yet created. Could go bananas and add some spelling errors. For what is a scroll text if there are no spelling errors? So let's add another command. Yeah, it feels quite illogical for me to. No, did we? We didn't fix the register because we're not done with the scroll text yet. We're soon done. And when we don't plan to add anything more, then we'll update these to save some cycles. We'll have a look around at the other stuff as well. And what I think we'll do the most is reordering the main loop strategically so that the CPU has something to do during some of the blitz to prevent some unnecessary wait blitz. split weights, whatever you want to call them. So the bounce command is working. So the next command will not act upon this piece of code. Will act upon the scrolling code. We have no means of stopping the scroller yet. We'll have to add that. And the next command looks fairly similar. And we'll have to have a parameter with this. And that is, well, essentially how many frames it should stop for, which I guess is fine. I'm thinking like 3 seconds. So we might end up needing that frame counter anyway. And it has no way of toggling, so this will not be a toggle. Or stop is fine. And we can then do what we did up here and, well, read another character and put that value in this command variable. I should rename that to command bounce then. And I'll put it straight into command stop, because I will then read the next character from the scroll text to keep everything in sync here. So after each action on the scroll text that is not a proper character, you need to load the next character, because immediately after you will plot a character. Maybe I should actually do this. Well, I guess it will technically prepare the buffer. Well, let's keep that for now, and if we have to move that to the code that unpauses the scroller, then so be it. Main thing is we have a parameter for this second command. That is how many frames it should stop for. And for that we'll need a frame counter and a counter. A count down. So this looks okay now. Oh, short-term memory loss. And that will be a word actually. And it will put the value directly into the countdown register. Count it down until 0. And if 0, it shouldn't stop, but keep working as normal. And then let's add the frame counter. Well, we don't need that now because we have a countdown. We don't need a frame counter because we'll count it down each frame. This will be our frame counter for a brief period of time. And we'll just make sure that the count we put in there. Okay. Need to clear D0, put the byte in there, write the word into command stop. And that should take care of that. And I also need to modify the scroll text to provide the parameter. 3 times 50 is 150. The reason for clearing instead of extending is that this is higher than 128, and if you extend a byte that's 128 or higher, it becomes a negative word. It's just how binary math works. So that's a 3-second pause, in theory only, until we add something here. So it will come to this command. It will plot the character after the countdown, then wait for that number of frames, and then simply the count will be 0 so that all goes back to normal. Such is the plan. And if we are to skip this, we are to skip it entirely and not update anything. Let's do this because I need to decrease it. And if it's non-zero, then I do nothing. I just subtract 1 from it. And skip it. And that should be it. Bit lazy to let the assembler take care of the missing symbols. Can also lead you into danger sometimes. But for now, it is fine. We have a scroller with 3 commands. First command is the bounce command. With a neat, I have to say it's a neat little micro jump there. Completely, I have no idea. Don't ask me. Called tech support in India. So the second one doesn't fit on there, and it was okay. So this all works. We're done apart from some small optimization things that will take place in the next episode. But I did see one small tweak that we had to make. So we needed to do this and this. And increase this. Let's do 180. And you can have a lot of fun adding commands to your scrollers. You can make them. A famous demo is demo coder is Taipan, then of Phalanx, who made 2 demos with a scroller that flipped around and did all kinds of things. Comes a little bit late, perhaps. Could move it one character to the front. Now, what you can't do, well, what you can do if it's not centered. Yeah, I was gonna say you can't act on commands in the middle of characters unless you write some special code. If you want that kind of precision. It might be the eye and bouncing that's messing it up. Let's see if am I handling? Probably not handling the exclamation point. Might be able to fix it that way. So we thought that this should come one character sooner. Let's have a look. Glad I don't have any commas before the scroller starts bouncing. Now it's centered. It has character, I like it, and it's centered. All nice and patched up. So let's wait for it to wrap, and then it's a wrap. And we'll keep the red raster line at the bottom there. We'll move it up and down and time various, we'll profile the demo and check which parts take the longest time and work on those. See if it wraps. And until next episode. For now, this is Photon signing off. Thanks for watching. See you in the next one.